the universe is a place so vast and mysterious that it often feels impossible to truly grasp its enormity. In fact, as Brian Cox, the renowned British physicist, eloquently puts it, there are many things about the universe that are not only difficult to understand but are, in a way, incomprehensible. One of these mind-boggling concepts is size and scale. Imagine, if you will, standing on the edge of an infinite abyss that stretches out in every direction, far beyond the limits of your vision. How would you feel in such a place? How would you even begin to comprehend the immensity that surrounds you? These are questions that truly challenge our perception of reality. But they are also questions that science is slowly helping us to answer, pushing the boundaries of what we thought was possible. Brian Cox takes us on a journey through this unfathomable space, helping us better understand just how vast the universe really is. He uses simple yet profound analogies to convey the incomprehensible. Take the example of an atom. If we imagine an object the size of a peach placed inside the Earth, the distance between the peach and the outer shell of the Earth is analogous to the space between the nucleus of an atom and its outer shell. It's incredible to think that within this tiny space, there are only a few particles, and the rest is simply empty space. This idea, that most of what makes up the atom, and indeed, the universe itself, is empty, might be difficult to wrap our minds around. And yet, this emptiness, this vast nothingness, is what constitutes most of the universe as well. We look out into the cosmos and see a universe teeming with stars, galaxies, and nebulae, but in reality, these structures exist in a vacuum, a vast nothingness. We are able to see and study the light emitted by stars and other cosmic phenomena, but the space between them is mostly void, the distances measured in terms so large they defy imagination. A single star, like our Sun, is estimated to consist of around 10 to the 57 atoms, a number so large it's practically meaningless in our everyday lives. To put it into perspective, this number is 1 followed by 57 zeros. Even this, however, is just a drop in the ocean compared to the scale of the universe. When we talk about the distances between stars, we often use light years as a unit of measurement. A light year is the distance that light can travel in 1 year, and it amounts to approximately 9.46 trillion kilometers. That's about 5.88 trillion miles. The vastness of the universe becomes even more astonishing when you consider the unimaginable number of stars and galaxies that exist. There are thought to be around 2 trillion galaxies in the observable universe. That's a number so large that it's hard to fathom. Even more astounding is the fact that this is just an estimate based on our current ability to observe the local universe. Beyond what we can currently see, it's likely that there are far more galaxies, stretching into regions of the cosmos that remain beyond our reach. As Brian Cox highlights, we have only explored a tiny fraction of what lies beyond our reach, yet this small section already reveals an awe-inspiring variety. No two galaxies are the same. Each one is unique, with its own shape, structure, and history. While galaxies may share certain broad characteristics, such as spiral shapes, elliptical forms, or irregular configurations, each one tells its own story through its stars, planets, and the way it has evolved over time. Some galaxies, like our own Milky Way, contain hundreds of billions of stars. Others, such as the dwarf galaxies, may only house a few million. But when you begin to multiply these numbers, you arrive at a figure so large that it's almost impossible to imagine. Among these galaxies, there are some famous examples that have captured the imagination of scientists and stargazers alike. The Andromeda Galaxy, for instance, is our nearest large neighbor, and it's on a collision course with the Milky Way. Over the next several billion years, the two galaxies will eventually collide, merging to form a new, larger galaxy. Another famous galaxy is M51, also known as the Whirlpool Galaxy. This beautiful spiral galaxy is famous for its well-defined structure, with a prominent spiral arm wrapping around its core. Then there is the unusual Hubble's object, a ring galaxy that has a completely different configuration from most other galaxies. These galaxies, along with many others, represent just a fraction of the vast number of galaxies that populate the observable universe. It's not just the galaxies themselves that are fascinating. The stars within them are equally remarkable. Some stars are relatively small, while others are giants. Our own Sun, for example, is a medium-sized star. But it's only one among countless others. Some stars are so massive that they outshine our Sun by 1,000 times over. These supergiants can burn through their fuel much more quickly than smaller stars, but their incredible size makes them highly fascinating. Take, for example, the hypergiant star Uy-Scuti. With a radius 1,700 times larger than the Sun, if Uy-Scuti were placed in our solar system, it would extend far beyond the orbit of Jupiter. Stars like Uy-Scuti give us a glimpse into the sheer scale of the universe. But beyond stars, another object that captures the imagination is the black hole. These mysterious entities have gravitational forces so intense that not even light can escape their grasp. They are remnants of massive stars that have collapsed under their own gravity, creating a singularity, a point where the laws of physics as we know them break down. The largest black holes are known as supermassive black holes, and they reside at the centers of galaxies. One such black hole, located in the center of the galaxy M87, is known as M87* and has a mass 6.5 billion times greater than that of our Sun. The discovery of such objects has opened up new frontiers in our understanding of gravity, space-time, and the nature of the universe itself. As we venture deeper into the universe, we reach beyond the stars and into the quantum realm, where the very fabric of space-time behaves in ways that challenge our understanding. This is the world of particles, some of which are so tiny and elusive that they defy our ability to directly observe them. For example, at the heart of every atom, we find protons and neutrons, which are themselves made up of even smaller particles called quarks. These quarks are the fundamental building blocks of matter, and they come in 6 different types, or flavors. The interactions between quarks, mediated by the strong nuclear force, give rise to the matter that makes up everything we see around us. Even smaller than quarks is the Higgs boson, often referred to as the God particle. This elusive particle was theorized by physicist Peter Higgs in the 1960s and was finally discovered in 2012 at the Large Hadron Collider. The Higgs boson plays a critical role in the standard model of particle physics, as it is responsible for giving mass to other particles. However, despite its importance, the Higgs boson is incredibly fleeting, making it very difficult for scientists to study. It's a reminder of just how strange and counterintuitive the quantum world can be. In addition to the familiar particles of the standard model, there are other, more mysterious entities that exist in the universe. One such example is the neutrino. These ghostly particles are nearly massless and can pass through ordinary matter with little to no interaction. Neutrinos are produced in vast quantities in processes such as nuclear fusion in the cores of stars. They are incredibly difficult to detect, but they provide scientists with valuable information about the fundamental processes that drive the universe. Beyond the visible matter that makes up stars, galaxies, and planets, there is another invisible force at play: dark matter and dark energy. These two phenomena together make up about 95% of the total energy content of the universe. Dark matter is a mysterious substance that does not emit, absorb, or reflect light, making it undetectable by conventional means. However, its presence is inferred from its gravitational effects on visible matter. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe. Together, these forces shape the evolution of the cosmos in ways that we are only beginning to understand. Some scientists even speculate that dark matter and dark energy could form an entirely separate universe, one that follows different physical laws than our own. As we contemplate the sheer scale and complexity of the universe, we are left to wonder about our place in it. It's easy to feel small and insignificant in the face of such vastness. After all, how could humans possibly matter in a universe so enormous and filled with such cosmic wonders? But, as Brian Cox points out, there is a profound truth that we must remember: our consciousness shapes the universe. We are not just passive observers, we are the conscious beings through which the universe becomes aware of itself. In a sense, the universe only exists because we are here to witness it. It sounds strange, but this idea is at the heart of many philosophical and scientific reflections on existence. As human beings, we have a natural inclination to explore. From the earliest days of our species, we have sought to understand the world around us and to push the boundaries of what is possible. We have looked up at the stars and wondered about their nature, and now, we are beginning to unlock some of the universe's deepest secrets. But as we look out at the cosmos, we are reminded of just how much we still have to learn. There are still mysteries that remain, and many of them may never be fully understood. Yet, humanity's capacity for exploration and discovery has brought us closer to the universe than ever before. In the near future, space travel may become more commonplace, with missions to other planets, moons, and even stars becoming a reality. The distances involved, of course, are staggering. Even with the fastest spacecraft we have today, traveling to the nearest star would take thousands of years. But that doesn't stop us from dreaming. We are already working on technologies that could make faster-than-light travel possible, such as the theoretical concepts of the warp drive or the folding of space-time. The history of human progress shows us that what seems impossible today can often become reality tomorrow. Just a few centuries ago, the idea of traveling to the moon seemed like pure science fiction. Now, we have not only landed on the moon but are also working towards sending humans to Mars. The human drive for exploration knows no bounds, and as we continue to push the limits of what is possible, who knows what incredible discoveries the future will bring. We may one day find ourselves traveling between stars, discovering new worlds, and unraveling the deepest mysteries of the universe. In the end, whether we are contemplating the infinitesimal particles that make up the fabric of matter or the grand cosmic structures that stretch across billions of light years, we are part of a vast and wondrous universe. The scales we encounter, from the tiniest subatomic particles to the most enormous galaxies, remind us of just how small and yet how significant we are. The universe is vast, mysterious, and awe-inspiring. It is a place that challenges our understanding, but it is also a place that invites us to explore, to ask questions, and to seek answers. And in doing so, we come to realize that, in the grand scheme of things, our place in the cosmos is both humbling and extraordinary.